Hello dear students, welcome to ECE Academy Benefactor. In this class we will be seeing binary parallel adder. The topic is from combinational logic circuit unit. The subject name is digital electronics. So we are having two types of binary parallel adder and binary parallel subtractor. These two combinational circuits are there. In this class we will be seeing only binary parallel adder, covering the topics n-bit parallel adder and 4-bit binary parallel adder. Let us start the class. So, when do we need a parallel adder? A single full adder is capable of adding two 1-bit numbers and an input carry. That is, a single full adder can add two 1-bit numbers. It will add two 1-bit numbers and then an input carry, for example like this. In order to add binary numbers with more than 1 bit, suppose if you are having binary number A is having 2 bits, A2 and A1, and binary number B is having 2 bits, B2 and B1. This cannot be done using a full adder. In order to add binary numbers with more than 1 bit, additional full adder must be employed. So, single full adder is capable of adding two 1-bit numbers and an input carry. What is binary parallel adder doing? An n-bit parallel adder can be constructed using number of full adder circuits connected in parallel like this. So, here we have taken an n-bit parallel adder. It means the number A is having n bits, that is an, a3, a2, a1 and a0. Let us say that the A number is having these many bits and the B number is having n number of bits like Bn, so on, B3, B2, B1, B0. So, when you want to add an n-bit two numbers, binary numbers A and B, the diagram will be coming like this. So, you know the full adder is having three inputs, A0, B0 and input carry. Okay, full adder inputs are 3 and outputs are 2, sum and carry. So, the output of full adder is taken as S0. Now, the output of this Cout is acting as input to the next full adder. So, the input for this full adder is A1, B1, Cin. What is Cin? Cout of the previous circuit. The two outputs of this full adder is S1 and Cout. This Cout will act as input Cin for the next full adder. So, the inputs for this full adder is A2, B2, Cin and outputs are S2 and C0. Similarly, you can connect number of full adders. This is the nth bit adding full adder, which is having the inputs An, Bn and input is Cin. The output for this full adder is Sn and Cout. Okay, so this is the block diagram of n-bit parallel adder. Now, let us design a 4-bit parallel adder using full adders. So, 4-bit means let us add two binary numbers A and B. Each binary number is having 4 bits. Let the A number be having A3, A2, A1, A0 bits and B number is having bits B3, B2, B1, B0. So, the first full adder will add A0, B0 with the input carry Cin as 0. Okay, it will generate the output S0 and Cout. The next full adder will add the bits A1, B1 and whatever is the carry here, that is added. The next full adder will add A2, B2, the next will add A3, B3 and so on. So, see this diagram, we are having for the 4-bit full adder, 4-bit parallel adder. 4 full adders are taken. The inputs are A3, B3, A2, B2, A1, B1, A0, B0. For the first full adder, the inputs are A0, B0. Initially, the input carry will be 0. This is very important. So, make C in as 0. The output of this first full adder is S0 sum and C out. This C out will act as input to this one. So, I written the input as C in. For this full adder, the inputs are A1, B1, C in. The outputs are S1 and C0. The next full adder inputs are A2, B2, C in, and the outputs are S2 and C out. The fourth full adder inputs are A3, B3 and C in. Outputs are S3 and C out. So, when we need to add two binary numbers having 4 bits, we need to design a 4-bit parallel adder in this fashion. Let us see the logic diagram of 4-bit parallel adder. So, binary number A is known as operand A and binary number B is known as operand 2 here. So, for this 4-bit parallel adder, the inputs are operand 1 and operand 2. Operand 1 means 4 bits of A. A3, A2, A1, A0. Operand 2 is binary number B having comprising of bits B3, B2, B1, B0. So, 2 operands are coming as input to this adder. Why it is known as 4-bit? Because each operand is having 4 bits. So, input C in is the input. Okay. Output for the adders are 4 bits sum output S3, S2, S1, S0, okay, and 1 C out. So, sum and carry are the output bits. Input bits are operand 1, operand 2 and C in. This is the logic diagram of 4-bit parallel adder. Okay. So, in combinational circuits we are having adders and subtractor. Under adder we have to prepare half adder, full adder, binary parallel adder. And coming to subtractor, you need to know about half subtractor, full subtractor and binary parallel subtractor. We will be seeing binary parallel subtractor in the next class. So, in this class we have understood what is the need of a parallel adder and how to design a 4-bit parallel adder. I hope the class is clear. If you have any queries, you can post in the comment section. Thank you. Good luck, students.